Okay, so good morning, and today we are going to take a look at the Parallelogram Law of Forces as it relates to finding the resultant force of forces acting on an object. So if we have, as in the case here, two forces acting on a box, and we're assuming that the box has no friction with the ground, one force is 400 newtons acting to the right, and the other is 200 newtons acting to the left, right? We can represent this same situation as the diagram in the line diagram below, where the box is represented by that point and the two forces acting on the box are represented by the arrows. Now note that the arrows, the 400 newtons is a larger force, and therefore the arrow is 2 times the size of the arrow that represents the 200 Newton force acting to the left. So let's see if we can now find out what the resultant force on this block is. If we look at this new page, we can also redraw the situation with the block like this, right? The resultant force happens to be 200 newtons to the right. So it's very important to indicate the direction. So the 400 newtons basically is larger than the 200 newtons, and therefore we subtract them because they are acting opposite to each other, all right? And the resultant force happens to be 200 newtons to the right. This object will move, therefore, to the right in the absence of friction. Now let's just say, for example, we have a guy falling with a parachute here. The forces acting on this guy is gravity. Gravity gives him his weight, so his weight is acting downwards. And of course, the parachute traps some of the air, and as a result, you get air resistance. Now notice the weight is larger than the air resistance, and therefore the person continues to fall, but just not as fast. Now if the air resistance and the weight were the same, the person would remain stationary, right? Because then there will be no resultant force acting on the person. Currently, the resultant force is acting downwards, and that is why the person is falling downwards. If we remember correctly from Form 3 physics, the resultant forces cause motion. I'm now going to show you another page where we can redraw this diagram in simpler terms, so we won't have to draw this stick man and the parachute and so on. So that same parachute situation can be redrawn like this, where the resultant resistance due to the air, that's R subscript A, which is measured in newtons, it's a force, is acting upwards while the weight is acting downwards. The resultant force is a downward force, and the object will then fall to the ground. So in real life, we have forces acting on all objects. So for example, if we have this large boat that is coming into a harbor, very often what happens is that tugboats, two small tugboats, which are very powerful boats, will pull the large boat into the harbor safely. So if we look at the diagram there, we have a large boat, right, and tugboats A and tugboat B acting on the boat. Tugboat A is pulling at a force of 5,000 newtons, and tugboat B is pulling at a force of 6,000 newtons. So what our job is today is to find out what is the resultant force of the two tugboats and the direction the large boat will move. The first thing we must do in order to find this is use a scale, is to draw a scale diagram, right, which in this case is the parallelogram law diagram that we are going to draw, right? The diagram must be drawn to scale so that we can represent all the quantities, the forces that are acting on this boat correctly. Our first step is to find a scale that is suitable to represent the forces acting on this boat, okay? And I think that the most appropriate scale in this case will be 1 cm to represent 1,000 newtons. Your next step is to draw a line on your graph page to represent 1 of the forces. I will show you that line now. So if we were to look here, you draw a horizontal line to represent the force of 6,000 newtons by tugboat B. This line happens to be 6 cm because the scale we are using is 1 cm to 1,000 newtons. So 6,000 newtons will be 6 cm. Our third step is to use a protractor and measure the angle, right, and draw the next force or the next line. Definitely, in this case, the angle was 90 degrees. So you really didn't need a protractor, but the angles are not always 90 degrees between the two forces. So you're going to have to use your protractor to measure the angle correctly. You cannot average because this is an accurate scale diagram. So I drew the other force here, 5,000 newtons, and it's 5 cm long, as you can see. All right. Our next step is to complete the parallelogram. So basically, I will show you on the next page that we must complete the parallelogram. So what I did, I drew another line across here that is parallel to this one. And then I drew another line here that is parallel to this one. So this creates a parallelogram. In this case, it's a rectangle, right? But I want you to notice that I put the directions of the forces. The arrows indicate the direction in which the forces are going, right? So that's basically when the parallelogram is complete, okay? Our next step is to draw in, of course, the resultant force. This diagonal here is the resultant force. What this resultant force is basically the total force if you were to add up both the 5,000 newtons and the 6,000 newtons that are acting on the large boat, as in the diagram. So this notice I got a value of 7,800 newtons. What I did was that I was able to measure the length of this using my ruler. I got 7.8 cm, and since the scale is 1 cm to 1,000 newtons, I multiplied 7.8 by 1,000 and got 7,800 newtons. That tells me that the two tugboats are pulling the large boat with a combined force of 7,800 newtons, or a resultant force of 7,800 newtons. The thing is, if you notice, the resultant force always has two arrows. That's how you know that that's the resultant force. It's also always the diagonal of the parallelogram. Now, it isn't always a nice rectangle. It could be a square, it could be a rhombus, but it will be a parallelogram. Of course, what a parallelogram is an object that has a pair of parallel sides. So these two sides here are parallel, whereas these two sides here are also parallel. All right? And that basically is how you do the parallelogram law to find the resultant of different forces. Now, this can also be done by calculation using things like the cosine rule and the sine rule. But at this stage, we are responsible for being able to draw these diagrams. So I will post a question for you to do, a CSEC question, where you will complete the parallelogram. I hope that you can refer to this video at any point to remember how we go about doing this. Thank you.